Have you ever found yourself completely stuck, trying to figure out the perfect way to do something? Not just a good way, but the absolute best, most optimal choice you could possibly make? Well, it turns out there's an entire science dedicated to exactly that. Today, we're going to dive into something called operations research, which is really just the hidden science of making better choices. So here's our game plan. We'll start with that basic human desire, that quest for the best. Then we'll get into what this science of decisions is all about. After that, we'll trace its pretty wild history from the battlefield to Wall Street. We'll look at its strengths and its weaknesses, its powers and pitfalls. And to wrap it all up, we'll get a little glimpse into the weirdly beautiful geometry that makes finding a perfect solution even possible. At its heart, this is a puzzle we are all trying to solve, pretty much every single day. We've all got limited resources, right? Limited time, limited money, limited energy, and we're all just trying to get the most bang for our buck. I mean, really think about it. How do you decide where to put your savings to get the absolute maximum return? How does a company figure out its delivery routes to burn the least amount of fuel? Heck, how do you even plan your weekend to get the perfect mix of chores and fun? This isn't just about making a good guess, it's about finding the optimal answer. It's about optimization.
And this deep-seated need to optimize everything wasn't just left to chance, it actually led to the creation of a whole formal discipline. So let's see how this everyday puzzle kind of blossomed into a true science of decision-making. So what in the world is operations research, or OR as you'll often hear it called? Well, it's pretty much what it says on the tin. It's about applying scientific, mathematical methods to messy, real-life problems to figure out the single best way to use the stuff you've got. It's all about taking the guesswork and gut feelings out of the equation and replacing them with cold, hard data.
And listen, this is not some newfangled idea. This definition right here is from all the way back in 1946. It frames OR as a tool for leaders, a way to give them a solid, quantitative reason for the big calls they have to make. It's been a secret weapon and strategy for decades. And the origin story of operations research is just as cool as what it does. You see, this incredibly powerful science wasn't born in some quiet university lab or a fancy corporate boardroom. No, it was literally forged in the fires of global conflict.
So picture this. It's World War II. The British military is facing these incredibly complex problems. Like, what's the most effective way to deploy radar? Or what's the optimal search pattern for planes to find enemy submarines? So they brought in teams of scientists, mathematicians, physicists to solve them. And it worked. It worked so well that the idea spread like wildfire after the war. You can see here, by 1949, India had already established its first OR unit.
And from those military beginnings, oh man, OR has exploded into basically every field you can think of. It's used in agriculture to squeeze every last bit of yield from a field. It's used in finance to build investment portfolios. In marketing to figure out the best way to spend ad dollars. Just think about that for a second. The same fundamental logic that helped hunt submarines is now helping to run pretty much the entire global economy.
Okay, so this thing sounds like a superpower, right? But, and there's always a but, it's not a magic bullet. To really get a handle on operations research, we need to be honest about what it does brilliantly and, well, where it kind of stumbles.
So on the one hand, yes, OR is amazing. It gives you this logical, step-by-step way to find better decisions, and fast. But here's the catch. Building the mathematical models for these problems can be insanely complex. And more importantly, these models are just numbers. They can't really factor in fuzzy, unquantifiable things. You know, like human emotion or employee morale. And at the end of the day, a model is only as good as the assumptions you feed it. So it's a powerful guide for sure, but it's not a crystal ball.
So how does the math actually work? I want to give you a quick visual peek at one of the most basic ideas in OR that makes this whole finding the best solution thing even possible. And I promise, no heavy math, just shapes.
It all comes down to an idea called a convex set. Now, don't let the technical name scare you off. The idea is incredibly simple. A shape is convex if you can pick any 2 points inside it, draw a straight line between them, and that line never ever goes outside the shape. That's it.
Okay, check this out. This is a perfect example. Look at this polygon. Go on, mentally pick any 2 dots you want inside that shape. Now imagine drawing a perfectly straight line to connect them. See? No matter where you pick your points, that line is always going to stay tucked neatly inside the shape. Simple, right? That's a convex set. Now, let's look at this guy. This is not a convex set, and you can probably see why instantly. If I pick a point way over here on this arm, and another one over here, and I draw a line between them,
Whoops, that line travels outside the shape for a bit before coming back in. The moment that happens, boom, it's non-convex.
So, who cares? Why are we even talking about these shapes? Because this is the absolute key. In the world of optimization, when your set of possible solutions forms a convex shape, it's like a golden ticket. It guarantees that there is one single best answer. And even better, it tells the computers where to look for it, almost always at one of the corners or on one of the edges of the shape. It makes the impossible problem of checking every single option possible. Which kind of leaves us with one last big idea to chew on. If the science of finding the perfect answer tells us that the best solution almost always lives on the boundary, right on the very edge of what's possible, what's the hidden geometry of your own daily decisions look like? And are you exploring the edges?